Today we're going to talk about something called a sample space. So a sample space is just a set whose elements represent all of the possibilities that can occur for a given event. So let's say we're talking about flipping a coin. So we want to flip a coin. What are all of the possibilities that can happen when you flip a coin? Well, when you flip a coin, really, there are only two things that can occur. We can either land heads or we can land tails. These are all of the possibilities that can occur. So this is just the sample space for flipping a coin, either landing heads or landing tails. Now, when you're talking about probability, the sum of all of the probabilities for all of the events in a sample space will always add up to be 1. Right? So if we're looking at the probabilities for each of these, if we assume that the coin is fair, we assume that there's an equal probability of flipping heads and tails. So the probability of flipping a heads plus the probability of flipping a tails should be equal to 1. And like we said, if they have equal probability, the probability of flipping a heads is half. The probability of flipping a tails would be half of the time. So we add those up and they get 1. So this is a sample space. The sum of all the probabilities in a sample space should be 1. So let's take a look at this a little bit more. So we want to know, what is the sample space for rolling a single die? Sample space for rolling a single die. Now we're assuming that it's a six-sided die. Yes, there are more, but this is the most common kind of die, so we're going to assume that it's a sample space for rolling a six-sided die. Well, what are our options? We can either roll a 1, a 2, 3, 4, 5, or a 6. This is our sample space. We only have those options. That represents all of the possibilities of rolling a single die one time. So this says if a die is fair, what's the probability for each element in this space, in the sample space? So what's the probability of rolling a 1, a 2, 3, 4, 5, or a 6? Now, if a die is fair, meaning each event has an equally likely outcome, then we know that all of our probabilities should be equal, right? The probability of rolling a 1 should be equal to the probability of rolling a 2 or a 3 or a 4 or a 5 or a 6. Now, when you're calculating probability, the way that you determine the probability of something is it's just the number of times that your desired outcome can occur divided by the total number of possible outcomes. So if we wanted to roll a 1, there's only one way that that occurs out of a total of 6. Same as with a 2. 2, it's only one way out of 6. So all of these together, right, each one individually, has a probability of 1/6. If I want to roll a 1, I have a 1 in 6 chance. If I want to roll a 5, I have a 1 in 6 chance. Now, again, thinking about the idea that if we take the sum of all of these, it should add up to be 1. Well, the probability of rolling a 1 is 1/6, a 2 is 1/6, a 3 is 1/6, a 4 is 1/6, a 5 is 1/6, and a 6 is 1/6. Whoops, 1/6. So if we add all these up, that's 1, 2, 3, 4, 5, 6 sixths, or 1. So the sum of all their probabilities is 1.